In this problem, we're asked to look at a truss which is made up of members 1, 2, 3, and 4. There is a point load acting there at joint D, P, downward. And what we want to know is, as a result of that, what is the vertical deflection and what's the horizontal deflection of joint D? So the first thing that we recognize here is that we really need to have a dummy force. We can get the vertical component because there's a vertical force, but we need a dummy force PD at D in a horizontal direction. Again, because the question asks for the horizontal component of deflection there at D. So I'm going to put a P sub D there. What we're going to do here is just run through a sketch of these solution. We won't give all the details, but just make sure that we understand the path that we need to take. The first thing that we do, as always, is look to see what equilibrium gives us. So equilibrium is going to consist of drawing FBDs for joints B and D. And we know here at B we have joint force F1. We have joint force there F3, joint force F2, equal and opposite force F2 on joint D. We have the dummy force PD, we have the applied force P, and then we have the member force there of F4. I'll call this alpha and beta here. I'm going to make X positive to the right, Y positive up. So if I look at my equilibrium equations that I'm going to write down for joint D, when I sum forces in X, I'm going to have the dummy force PD minus F4 minus the member force F2 cosine of phi, and for equilibrium that is a 0. So this is the angle there of, I said phi. Do I want phi? I want beta. Again, this is beta, and this is alpha. Okay, then when I sum forces in y, I'm going to get F2 sine phi. I'm going to have a minus p like that, and that is equal to a 0. If I look at joint B, then when I sum forces in x, I'm going to have minus F1 minus F3 cosine of alpha plus F2 cosine of beta, 1, 2, 3. For equilibrium, that is a 0. Summing forces in y, I get minus F3 sine alpha minus F2 sine beta, and that's equal to a 0. From this, what I will do is I will solve for my member forces of F1 and F2, F3, and F4. So what I have for F1 is going to be a P times cotangent beta plus cotangent alpha. F2 will be a P divided by sine beta. F3 is going to be minus P sine beta. And F4 will be my dummy force PD minus P cotangent of beta. So my strain energy U will add up for each member individually. So this is going to be F1 squared L1 over EA. F2 squared L2 over EA. F3 squared L3 over EA. And F4 squared L4 over EA. You can go through the trig to find the different lengths of L1, L2, and L3. And so, therefore, what we need is to use Castigliano to say that V sub D, which is going to be equal to minus partial U with respect to PD with P, I'm sorry, not with respect to PD, but with respect to P. And when we get through, we set PD equal to 0. So that's going to be L1 EA partial F1 with respect to P times F1 plus L2 EA partial F2 with respect to P F2 plus L3 EA partial F3 with respect to P F3. And lastly, I have an L4 partial F4 with respect to P. That's divided by EA times F4. And UD is, I do the same thing, but I do that with the dummy force, the PD. When I get through, I set PD equal to a 0. So L1 EA partial F1 with respect to the dummy force PD F1, L2 divided by EA partial F2 with respect to PD F2, L3 over EA partial F3 with respect to the dummy force PD times F3, and of course the L4 over EA partial F4 with respect to PD F4. So from above here we can see that the partial of F1 with respect to P is going to be equal to cotangent of beta plus cotangent of alpha. We see that partial F2 with respect to P, which we need for that first expression, is 1 over sine beta. Partial of F3 with respect to P is minus 1 over sine beta. And the partial of F4 with respect to the applied force P, that's going to be equal to minus cotangent of beta. So there are those. If we also look, we see that the only place that PD appears is in F4. So we can strike out this term, and this term, and this term, and that's what we'll put in there is going to be a 1. So again, V sub D is a minus partial PU with respect to P. The minus sign just is due to the fact that since we put Y positive up, okay, and P is given down. It's just a minor thing. U, on the other hand, we had to rely on using a dummy force in order to get that deflection. And we see that that's coming out to be simply our load F4, which is going to be a minus P cosine of beta as that. So, the key step was this. Dummy force, simply because we are asked to find the horizontal component of displacement. Other than that, it's a very standard kind of Castigliano one. We had a number of unknown forces, but the good thing was that the problem is determinate. We didn't have to solve together, all the displacements and forces together. We were able to get those right off the top. In order to find the displacement, that's when we used Castigliano.